Okay, team challenge number 13 is really just another one of these units conversion problems. So, we have the genome size for Prochlorococcus marinus strain Med4, and the genome size is 1,657,990 base pairs, which is a very small genome for a free-living organism, by the way, one of the smallest out there. All right. Given that the average base pair has a molecular weight of 660 grams per mole, what is the mass of DNA in a Prochlorococcus cell? Well, we have 1,657,990 base pairs times 660 grams per mole of base pair, okay, is equal to 1.094 times 10 to the 9 grams per mole of, not grams per gram, grams per mole of genome, okay? So if we had a whole mole of genomes, it would weigh this huge amount. However, each cell, on average, only has one genome copy, at least for this organism. So we have to take this number and divide by 6.02 times 10 to the 23rd molecules per mole, okay? And we will come up with a number which is 1.82 times 10 to the minus 15 grams per mole, or per molecule of genome, which is essentially per cell. Okay? If you cancel your units here, the moles will cancel out. We'll end up in grams per molecule of genome. That's not a very usable unit, so we'll call that 1.82 femtograms per cell. So that's how much DNA we have in a cell. The next part of the question is, if it were in a linear piece, and it probably isn't, it's probably a circular chromosome. But if we cut it and made it lie flat like that, how long would it be? Given the pieces of information that there's 10.5 base pairs per turn, that's a red herring, has nothing to do with the question, and a rise of 0.332 nanometers per base pair. These are just numbers that I got off Wikipedia, by the way. 0.332 nanometers per base pair. So all I have to do is multiply that by the size of the genome, and I end up with a length in nanometers of 550452 nanometers, which, just for interest's sake, I'll convert to micrometers. Micrometers. Remembering that this cell, this Prochlorococcus cell, has a diameter of 0.6 micrometers. So, like, the length of the piece of DNA is about 1,000 times longer than the diameter of the cell. So you can imagine that it's all spinned up in a little tiny ball in there. Okay, finally, it asks what the volume of the DNA is relative to the total volume of the cell. So if we think of the piece of DNA as a cylinder, which is what the question asks you to do, okay, imagine that it's a string that is like a cylinder, and it has a diameter of 2 nanometers, okay? And you know now that the length is 550,452 nanometers. You use the volume of a cylinder, which is pi r squared h. And you come out with a value of 1.73 times 10 to the 6th nanometers cubed. Okay? Now I can also figure out the volume of the cell in nanometers, where R here is equal to 300 nanometers. Okay, I've converted 0.3 microns to 300 nanometers. And this gives me a cell volume of 1.13 times 10 to the 8th nanometers cubed. So I can figure out what percentage of the cell that represents by dividing this number by this number. If I multiply by 100%, I end up with 1.5% of the cell volume is represented by the DNA in the genome. So even though it's a really long piece of DNA compared to the length of the cell, it's actually only representing, 1.5% of the total volume of the cell. So that's how you do that.